Hey everyone, this is Unit 5, notes number 14, average value, okay? Go ahead and write down the FLT here. You will need to briefly have your graphing calculator, so go ahead and make sure you have that out as well. Okay, so today's lesson is super straightforward. In terms of actually doing the calculus, that's the easy part, okay? The part that I want you guys to focus on here is what it represents. So we're learning how to find something called the average value, but we want to also understand what it represents, the context, okay? So I'll give you some scenarios here. Again, the calculus part is easy. Knowing what your answer represents, that's the major part there, okay? And we'll get more practice with this as we get into the AP prep. So if you feel like this is a little bit short, there's a reason why, because we got to get into the context of things, okay? So here we go. Okay, so you guys have seen this phrase before. The average rate of change. We call that AROC, right? Okay. You guys are learning something called the average value here. My highlight stinks. Okay, the average value. So what is the difference, right? And in short, they're really the same thing. Okay? It's all in how you read it. So the average rate of change, which is what you guys are used to, is slope. F of B minus F of A all over B minus A. Okay, this is something that you guys already know. All right? Okay, now, if you kind of pause in between the word average and rate, this would be the average of the rate of change in F of X. Okay? This phrase right here in green, that is the same thing as f prime of x. Rate of change, when you see the word rate, it's really derivative, okay? So to finding the average, what you do here is when you have a derivative, you can integrate it so that it goes back to the function, but to make it an average value, you divide it by the distance between the 2 points. Okay, they put it underneath here, but it's really just that 1 over b minus a here. That's what makes it an average value, okay? Notice how when you take the integral of a derivative, you just get f of x, the original function, and then you plug in your upper minus lower. But what I want you to notice is it's really the same thing. So what's the point if it's the same thing, right? It kind of depends on what they give you first to help you find out what you need, okay? So for instance, here on the left side, for average rate of change, all you need to know is what the function is to find the average rate of change. To find the average value, they will give you the derivative, and you have to find the average value of that, which is where you integrate, and then you divide it by b minus a. Two different things. It depends on what they give you. Okay, so let me give you another scenario here. So first, in short, this is your average value. Okay, you integrate and you divide it by b minus a. All right, so here's some context, okay? If you wanted to find the average acceleration, that's the same thing, and you guys should write this down, okay? That's the same thing as finding the average of the derivative of velocity. Okay? So the average rate of change, so if I were to just kind of change this highlight a little bit, the average rate of change in velocity is really just v, in this case, v of 15 minus v of 9 over 15 minus 9. Right? y2 minus y1 over x2 minus x1. That's what you guys are used to. Now, if I provided you the acceleration, right, to find the acceleration there or the average, you would just take the average value of acceleration, which is really you just integrating, but also dividing by the distance. But just notice how you end up with the same thing. So if I gave you velocity, then you would find it using the first method. If I gave you acceleration to begin with, then you could find it this way. So it all depends on if I give you the original function or if I give you the derivative. Here, if I gave you the original function, you would use this. If I gave you the derivative, then you would use the average value. Okay? Okay, so context. Let's say you guys had this equation here, okay? That is a derivative symbol. I added it on there, okay? Now, one thing to note, whenever you're given a derivative, that represents the rate of something, okay? So I'm going to give this some context, okay? This is the rate at which people enter Disneyland. I can't spell Disneyland. Disneyland. The rate at which people enter Disneyland, okay? So here's what I want you to do. On your graphing calculator, go ahead and call this y1, okay? So when you type this out, you got to be careful. You want to make sure that you divide it by the quantity of x squared minus 24x plus 160. Press play when you have that set. So this right here is the rate at which people enter Disneyland. So I gave you the derivative, right? If we wanted to find the average value, first, how do we find it? And then second, what does it mean? Okay? So here we go. We're going to integrate the derivative. Okay? And I want to, let's say, figure out what the average value is from 8 a.m. to 12 p.m. So in the matter of 4 hours, okay? So what I want to do here is I want to divide it by 12 minus 8. This right here is what makes it the average value, okay? So first, just how do I get the answer? And then secondly, what does it all mean, okay? So go ahead and type this onto your calculator, okay? That's 1 over 4 times math 9 from 8 to 12 of alpha trace y1 dx. So I'll do that too. Okay, so I'm actually going to break this up into pieces here. So that's 1/4. This right here comes out to 2,471.01043-ish. And then that comes out to 5,117.753. This right here is your average value. Okay? What the heck does that mean? So some things I want to note. 8 represents 8 in the morning. 12 represents 12 p.m. So that's time. Okay? So something that you want to remember. When you integrate a rate, the rate goes away. Okay? When you integrate a rate, the rate goes away because you go back to the original function. So what does that mean, right? So just the integral. Notice how I didn't include the 1/4, okay? This right here, if I integrate the rate, I'm just talking about the number of people that enter Disneyland. Okay? So this right here, 20,471 is the amount of people that enter Disneyland from 8 a.m. to 12 p.m. on a single day. About 20,000 people. I'm not sure how accurate these numbers are, okay? I just kind of made this up. All right? So again, this is about 20,471 people. Okay, obviously you can't have 0.01043 people, right? But approximately we have 20,471 people entering Disneyland from 8 a.m. to 12 p.m. Okay? So, think about this context here. The 1/4. What does the 4 represent? The 4 represents the amount of hours, because if you're going from 8 to 12, that's really hours. So if you're dividing it by 4 hours, this goes back to a rate. So this average value, okay, represents the amount of people that enter the park per hour. So roughly every hour, you got about 5,000 people entering the park. Make sure you guys understand context, okay? So everything inside that red or maroonish box or rectangle here represents the total number of people entering the park. When we divide it by 4, we're finding out the average rate at which people are entering the park. Roughly 5,000 people are entering the park per hour. So again, context, all right? So if you just integrate alone, that represents the number of people entering Disneyland. If you find the average value, that's how many people are entering Disneyland every hour. Okay? And that's it. All right? So finding the average value is very straightforward. Context, it'll take some practice. So big takeaways, remember that when you integrate a rate, you get rid of the rate. When you integrate a rate, you get rid of the rate. Okay? Okay, so I mean, if you ever pursue calculus in the future, right? Sometimes they'll call this average value the mean value theorem for integrals, but who cares? Okay, it's really the same thing. Okay, so I think I have 1 or 2 examples for you guys. Okay, write this one down here. Press play when you're ready. So we're going to step away from context for a little bit. We're just going to focus a little bit on the calculus, okay? So this is how you would normally find multiple choice questions on the calculus exam, okay? Find the average value of the function f of x on the interval from 1 to 2, okay? So here we go. To find the average value, we would have to integrate the function, and the bounds are going to be the interval from -1 to 2. All right, so here we go. If we had to integrate, let's say we didn't have access to a calculator, right? The integral here would just be x plus x cubed over 3 from -1 to 2. Does this represent the average value? Okay, press play when you're ready. This is just the integral. So remember, to make it an average, you have to, let me use a different color here. You have to divide it by the distance between the two values. So 1 over 2 minus -1, which is really 1 over 3. Okay, that 1/3 is what makes it the average, okay? So here, what you're going to get is 1/3 upper minus the lower. So in this case, it's 2 plus 2 cubed over 3 minus -1 plus -1 to the 3rd over 3. Okay? And the rest I'll let you figure out. It's just computations there. Okay? But that 1/3 is what makes it an average value. Okay? Keep that in mind. And that's it. Okay? Here's a released multiple choice question from the AP exam. Find the average value of. Okay. Try this one here. It's been a while since we've done this one concept, but I want to see if you guys remember, okay? Press play whenever you're ready or whenever you need assistance. Okay, so right away I see average value, so I know I have to integrate the function from 0 to 2, and to make it average, it'll be 1 over 2 minus 0 in this case. Okay? This one here, the only way to integrate that, if you guys recall, I noticed that there's a function inside of another function. So this would require me to use u substitution. So I'm going to let u equal x cubed plus 1. So du would be 3x squared dx. And I kind of have that right here, right? Almost a perfect fit. So x squared dx, if I move the 3, it'll equal 1/3 du. All right, let me make some more room here. Okay, so this is 1/2 times the integral of the square root of u 1/3 du. Okay, now this is in terms of u. Your bounds have to change a little bit here. Up here, x was equal to 0 and x was equal to 2. So to figure out what the new bounds are, you just plug these back in here. So if x is 0, 0 cubed plus 1 is just 1. If x is 2, the upper bound, then 2 cubed plus 1 is just 9. Okay? So here we go. This is 1/6. The integral of u, the square root of u, or u to the 1/2, is going to be u to the 3/2 over 3/2 from 1 to 9. Dividing by 3/2 is the same thing as multiplying by 2/3, so I'll take that out. So that's just u to the 3/2 from 9 to 1. And I'm showing all of my work here. Eventually, you guys are going to be able to cut corners. This is going to come out to 1 over 9 if I reduce it. 9 to the 3/2 minus 1 to the 3/2. All right. Okay, these are small details. Please don't let this overshadow the whole idea of the average value, okay? This is 1/9. So here I have to square root and then cubed, or cubed and then square root, but I would rather square root first. The square root of 9 is 3, and 3 cubed is 27. Okay, the square root of 1 is 1, and 1 cubed is 1. So this comes out to 26 over 9, which is one of the choices here. Boom. Okay. Now, if you were able to set it up, you're good to go. You might recall the u substitution. If you didn't, don't sweat it. But get to kind of revisit old topics that you may have forgotten. Okay? There you have it. Average value. Setting it up is pretty easy. Now, integrating, you may run into u substitution, but that's pretty much it. Okay? So go ahead and try it out. We'll work more in the context when we get to the AP prep. But finding the average value, just make sure you know how to set it up there, okay?